Hello everyone. So today I'm starting a new series on machine learning algorithms. So you can find these problems on my new playlist of machine learning algorithm, and here we will solve the and come up and write the algorithms related to machine learning. So that is the idea, and let's dive into solving the problem. So today we are solving this problem number linear fit algorithm. I found this into this one website called Strata Scratch. It's a good problem and it's a real life practical problem. And this problem says that we have to write an algorithm that linearly fits given inputs and outputs the slope and intercept of the linear function. Okay, and the test cases are we have outputs and description. So if I take one input, so if I plot these basically on my graph, so this is how it would look like. So this would be our graph, and it is asking us to plot these values. So the values are, the first value is we have 10.5, then there is 35.3, and then there is 19 in between. So 19 would be somewhere in between these, more close to 10.5. So here it is 19, then we have 47.8, and in the end we have 25.0, and initially we have 8.1. But the output for these inputs are, so for 10.5 the input is 0. So here is the point. Let me plot it with different color. So this is 10.5 at 0, then we have 35.3 at 1, so this is 1 basically, then there is 19 at 2, so this is for 2, we have 19, this is the 19, and then for 47.8 we have 3, so this is 3. So this graph is not accurate, but it is an approximation of what we want to do. And then for 25 we have 4, so at 4 we have 25 input, and then at 8 we have the highest value 5. Okay, so these are our points which I have plotted on the x, y, or Cartesian coordinate plane, or a machine learning plane, whatever you want to say, but these are simple independent and dependent axes, and we need to come up with one linear fit algorithm that can plot this line such that the errors from these points of this line are minimum. So this is, if I say this is E0, then this was E2, and this was E1, and this is E3, this was E3, yes, this was E3. So these all errors summation is minimized. So I'm going to write the algorithm, and then I'm going to show you how I reach to these algorithm formula, or the slope and intercept values for this. So the general fit, so the linear fit says that if our line is something like this, a naught plus a1x plus error, and we are trying to minimize all the summation of errors for I is equals to 1 to n, n is number of points or coordinates, and the slope is m, which is slope, and it's come out to be n into summation of xi yi minus summation of xi yi individual product divided by summation of xi square times n minus summation of whole of x size square. So this is our slope formula, which I prefer it calling as a0 because our line was a0 plus a1x, and our a1 is nothing but summation of y minus summation of minus a1 into summation of xi for all the coordinates values divided by n. So these are our formulas, and this would help us finding the general linear fit for the algorithm for the straight line that we are going to pass through all these points such that our residual error is minimum. And the derivation I will show you after the code that I'm going to write now. So the first thing that we are going to need is that we need to define our points. So our n is the actual number of points, how many points we are getting, and I'm using decimals because to hold the precisions of the values that I'm going to calculate. So for that I'm using decimal from the Python library decimal simple. So let's define our x. So this is our summation of x. So which is just the how we are going to sum all the inputs. So this is decimal x or for x in our inputs. So the input values make up the x, and similarly the model value of y is the output. We are, like I described before, the I values. I basically the indexes at which these inputs are present. So these are in for I in range length of input that we have, and now we need to calculate the summation of x squared like we described that because we're going to require that, and which is the sum of the x values that are we going to have into our input. So for x in inputs, and similarly we are going to need one summation of xy as well. So that is the product of x and y values. So the y values are the indexes into our equation, and we need to multiply these with the i's, which are the y values in the range of length of inputs that we are going to have. So this would make up this will give us the summation of x and y, and simply now I will write the formula like I described. So this is n times summation of xy and subtracted by sum of x and product times sum of y divided by n times squared sum of x. So that is squared sum x, and we need the summation of x times 2, basically summation of x squared. This is the formula for slope, and we need to write the denominator. So the denominator I have written, and we need to now call our intercept. So the intercept is summation of y minus the slope that we are going to get from the from just above, and times the x value that are we going to have, and we need this divide by n, and in the end we'll return these float values of slope and intercept that we just calculated now to match the output that we are going to have. Intercepts. Now let's run our solution and see if I have not performed any error, and submit our code to check how it performs. So it says I have made some error of for I in a range. This is the closing bracket, this is the opening bracket, and we need I because I forgot to mention I. And now let's run it again. So there is one more error of float. So this is float. Now let's run it again. So it is saying that I'm missing some values for small inputs. So we have summation x. Okay, and the x is decimal values for x in inputs. The I is the making the y values, and sum squared. We need to make this squared times 2, and the decimal values for summation of x, y. Now let's run again and see how it performs for these new values that I have had. Okay, so that has been accepted. So this is the algorithm for linear fit. It's a basic algorithm, and this is the first algorithm that you learn in machine learning. And as promised, now I'm going to show you how I come up with these formulas, or these are basically general linear fitting formulas or derivations, or if we want to do curve fitting on plane, then we use these concepts. So these are very minute, easy concepts to grasp, and I'm going to show you that what we need to do now to come to these formulas that I have written about, like how I arrived to this formula. So these are nothing but these are called linear fits, or and it comes from curve fitting in maths, and this you have must seen in different branches. You can find this in data science, and you can find this in mathematics, advanced mathematics as well, or statistics. So this thing is called linear curve fitting. So what we are trying to do in this part basically is we have this general points that we have mentioned, like we have these initial points, and we need to find one general lines such that the errors for all these positions, that e1 e2, this errors, that these are minimized in our when we make one line fit all through these, passing through these points. So if I model this, then it would be something like we are doing y is equals to a naught plus a1x, but that would not be so straightforward. So what we'll do is we'll add one error function that would give us help us to minimize this error and make this straight line fit all these points. So now what we'll do is that we'll write e is nothing but y minus a naught minus a1 of x, and this is for just one point. And if I apply it for all the points that we are going to write, then we can write it as e of I is yi minus a naught minus a1 of xi. So this is for the general all for I belongs to 1 or 0 to n. That would be the best. Or in terms of computer science we are writing, then would be 0 to n minus 1. And what we are trying to do is we are minimize our summation of e of I for I is equals to 1 to n, where and this summation will operate on all the values of y and x as well. So this would be I is equals to 0 to n minus 1. And for general purpose this will work. So and now all we need to do is write this in terms of now all we need to do is find this how we can minimize this error function that we are going to have. So I'm going to rename it as residual error that operates from I is equals to 0 to n minus 1 of ei, and this is nothing but summation of I is equals to 0 to n minus 1, and where this y of I is the measured value that we have, and we are subtracting it with the model value that we are going to predict, and we need to do the now we need to do what we'll do is like we'll apply modulus, because we need to take just the positive values of the errors. So what we'll do is we'll apply absolute modulus, and now to remove the modulus we'll take the square of this function. So where this square gets minimized, that would be our minimum point of yi measured minus yi model. So this would be the general algorithm which we need to minimize. And to minimize, what we can do is we can just differentiate this SR with both with first we'll differentiate it with the parameter a naught, and then we'll differentiate it with the parameter a1, which is basically slope and intercept, to find the minimum values of both these a naught and a1. So now we can write it again. So if I write it this, so this would become 0 to n minus 1 yi minus a naught minus a1x square times ai. So differentiating it with the a naught variable will give us minus 2 times summation of yi minus a naught minus a1x, because we are using the chain rule to differentiate. And if I differentiate it with the a1, which is slope, then we'll get 2 times summation of yi minus x, now a naught minus a1 into xi. And since we are differentiating with a1, so on chain rule everything else will become 0 except for xi. We'll have one more xi. So let's name these equations as 1 and 2. And to find the minimum and maximum, what we'll do is we'll set our derivatives to 0. That gives us the minimum and maximum points, or the saddle points, the to achieve the minima. So for that, this will give us the minima, and on setting up these two minima, what I will achieve is that the first equation and second equation, this would become like this. So the first will be summation of yi minus a naught. So the summation operator, I'm also adding the operating the summation operators on the every variable that we are going to have, that is minus summation of a1 x1. So since x1 a1 is a variable, it could be taken outside, that I will do in the later. And so for the second equation, this is summation of xi minus yi. I'm multiplying it simultaneously, minus summation of a naught into x1, and similarly summation of a1 into x1 squares. So these, let's name it these equation as 3 and 4. And one thing we know is summation of a naught is nothing but n times adding the a naught values, so that will be putting in the original equation that we have and bringing out this to the left hand side. So this will give me n into a naught is equals to n into a naught plus summation of a1 xi is equals to summation of yi. And similarly from 4 we can derive that summation of xi times a naught plus summation of xi square times a1. This would give me summation of xi and yi. So what I'll do is we can take out a naught. Since a naught is a variable, we can take out directly a1 out from the xi, from the product with xi, so it has no effect on the addition that we are going to do. So this would be the equation number 5 and 6. And now what we'll do is we'll write it in the form of matrices so that we can easily see that what is going to happen. So this is n times summation of xi, summation of xi. So I'm using both the conventions, so don't get confused with that. It's just I'm writing it xi sometimes like this and sometimes like this xi. So these both are the same. They are nothing but they are no difference. Summation of xi square, and we can use a naught a1. We are multiplying this to get the values of summation of yi. So this is yi and summation of xi yi. So if you see, this is nothing but system of linear equation like this: x a into a is equals to y, and all we need to do is we need to multiply with inverse of x to get the values of y. So that is a is equals to x inverse y. And now that we have our x in this form, like we have x is n into summation of xi. Here we also have summation of xi and summation of xi squared. So all we need to do is get the inverse of this x, and we know the matrix inverse for any matrix is nothing but x is equals to, if we need to find the inverse, then inverse of a matrix x is nothing but adjoint of that matrix divided by determinant of that matrix. So for this it would be looking simply like this: x inverse would be 1 upon n times summation of xi square minus summation of xi whole square. So that would be the determinant, and the adjoint would be summation of xi square summation of, and here it would be n, and these are the adjoints of matrices. So this would be the inverse of the x matrix. And what we'll do is now we'll just plug in these values back into this equation so that we can now find our a naught and a1 from the matrices that we just calculated. So what I calculated is this is n into summation of xi square minus summation of xi whole square times the no first was the matrix. The matrix values are summation of xi square minus summation of xi minus summation of xi and n. So this is the x inverse, and we have on our y we have summation of yi, summation of xi and yi. Now we can clearly see how our a1 looks. So our a1 looks like this now. So if I find a1, then we'll be taking the product of first row with the first column. So this would make our product to be summation of so for a1 we will be using the last row. So this row will be using to product with these columns. So if I mark it with one shape, simple. So we are multiplying these row values with these columns values to get the value of a1. So that now our a1 would be minus of summation of xi into summation of yi plus n time summation of xi yi plus n times summation of xi yi divided by n times summation of xi square minus summation of whole of xi square. So this is the formula that I showed you initially, which was over here. It's the same formula that we have written down below, that I have written down below. And the a naught values are nothing but summation of, if you open this up, then it would be summation of yi minus a1 times summation of xi divided by, and after plugging in the values of a1 into this above equation, we'll have these a naught and a1 values like these. So this would be the two formulas, or slope and intercept, for the equation that I just showed you for the linear foot algorithm. So I hope you like my solution and the derivation part for this algorithm that I have come up with. And you can find this solution on my channel. Please like and subscribe, and I will see you tomorrow with some new algorithm to catch up with. Thank you and have a nice day.